Hello everyone, welcome back to Think, Understand and Bloom with Rasheeda. In today's video, we are going to learn how to formulate a linear programming problem for a minimization case. In the previous video, we learned how to formulate a maximization problem. In this video, we'll understand how to formulate a minimization problem step by step. Let's begin by understanding the given problem. Here in the question, they have given the two essential vitamins, vitamin V and vitamin W. These two vitamins are available from two different foods, F1 and F2. The cost of 1 unit of F1 contains rupees 3 and the cost of another unit of F2 contains, that is, rupees 4. The problem also tells us how many units of each vitamin are available in 1 unit of each problem. The daily requirement is at least 60 units and 75 units for vitamin V and vitamin W. And our task is to decide how many units of F1 and F2 should be purchased so that the daily vitamin requirement is satisfied at a minimum possible cost. To understand the information more clearly, let's first represent it in a table. Before we start formulating the problem, let's first identify where it is maximization or a minimization problem. A simple way to identify the type of problem is by looking for keywords in the question. Keywords such as minimum, minimize, least, cost, requirement usually indicate a minimization problem. In this question, the words daily requirement, at least, minimum cost are clearly mentioned. Daily requirement, at least, minimum cost are clearly mentioned. These keywords tell us that we have to satisfy the required amount of vitamins while keeps the total cost as low as possible. Therefore, this is a minimization problem. Now, let's formulate the problem step by step. Let's start with the Step 1, that is a tabular form. As you can see, the table summarizes all the information clearly. It shows the number of vitamin units available in each food, the daily vitamin requirement and the cost per unit of each food. Now let's formulate the linear programming problem step by step. So firstly, before moving to the next step, we will fill this table so that it will be easy to go for the decision variable and then objective function and formulating a final LPP. Okay, as given in the question, 1 unit of F1 contains 2 units of vitamin V and 3 units of vitamin W. This is the food F1. 2 units of vitamin V and 3 units of vitamin W. Next, 1 unit of F2 contains 4 units of vitamin V and 2 units of vitamin W. 4 units of vitamin V for the food F2 and 2 units of vitamin W for F2. Now, here they have given a daily requirement in the question. Daily requirement of vitamin V and W are at least 60 units and 75 units respectively. For vitamin V unit, it's a 60 units and this is a 75 units. Next, we have to fill a cost per unit. Cost per unit they has given in the question. The respective prices per unit of each food are rupees 3 and rupees 4. This is for a food F1 is a rupees 3 and for food F2 is a rupees 4. After taking all the details in a tabular column, we'll move to our next step, the first step of a linear programming problem, that is a decision variables. As we have mentioned our tabular form, our next step will be a decision variables. That is our two decision variables we have, that is f1 and f2. We will represent it as a x1 and x2. Let x1 is equals to, these are our decision variables because they represent the quantities we need to determine. Next step, we are moving to the objective function. Our next step is the objective function. As given in the question, the respective prices per unit of each food are ₹3 and ₹4. So the cost of a 1 unit of food F1 is a ₹3 and a ₹4. We'll write, since our objective is to minimize the total cost, the objective function becomes, it's a minimization problem. We will write minimize z is equals to 3x1 plus 4x2. Our next step is a constraints. We are moving to the next step, that is a constraint. As given in the question, as the F1, food F1 contains 2 units of vitamin A and 3 units of vitamin W. With the help of the question, we have written in the table. With the help of this table, we will write the constraints. For a food F1 and food F2. From the table, we can write it as a 2x1 plus 4x2, and we will write the symbol as a greater than is equals to, because it's a minimization problem. In the previous problem, we wrote it as a less than or is equals to, as it is a maximization problem. So for the food F1, we will write it as a 2x1 plus 4x2. This is a greater than or is equals to, the given daily requirement is a 60. For a food F2, it is a 3x1 plus 2x2 greater than or is equals to 75. The minimum daily requirement is a 75. Here we have a constraints and a objective function. So finally we can write our LPP model followed with the objective function, that is a minimize z is equals to 3x1 plus 4x2. We can say it as a cost per unit in rupees, that has given already in the question. Next, subject to the constraints, we have a 2x1 plus 4x2 greater than or is equals to 60, 3x1 plus 2x2 greater than or is equals to 75. Non-negative constraint, we can write x1, x2 should be greater than or is equals to 0. The quality of food cannot be negative. Therefore, we can write it as a x1 and x2 greater than or is equals to 0. This is the required LPP formulation for the given minimization problem. I hope this step-by-step explanation helped you understand how to formulate a minimization problem. Thank you for watching. See you in the next video.